One of my favorite ways to factor is when I'm able to identify a particular object as a difference of two squares, which means that the first term is a square minus a second term, which is also a perfect square. And so I wrote several examples on the board that have a little bit of a feel like that. Basically what that means is then that if I have something squared minus something squared, and I want to factor that out, it's going to factor into a minus b times a plus b every single time. And how I know that is we kind of work the problem backwards. Let's multiply this out. A squared plus ab, middle terms minus ab, last terms b squared. Notice that the middle terms cancel each other out, so I'm left with a squared minus b squared. So if I'm able to identify that pattern sometimes when I'm factoring, I'm able just to understand that this factors cleanly into a minus b times a plus b. So let's look at my first one. X squared minus 4. It's a difference of two squares. So that's going to factor into x plus 2 times x minus 2. My second one, 81x squared minus 49. Everything in there is a square. So this will factor down to 9x minus 7 and 9x plus 7. It doesn't matter if you have the minus first or the plus first. What matters is that both of these terms will have the same digits, and one will be a minus, one will be a plus. The next one, 9 minus x to the 5th. I'm going to have 3 minus x, or x to the 10th. I'm going to have 3 minus x to the 5th and 3 plus x to the 5th. The hard part here might be to remember is x to the 10th. What times what? What times itself makes x to the 10th? And just a little bit of a remembering, x to the 5th times x to the 5th. When I have like bases, I add the exponents. So you can see that x to the 10th really is x to the 5th times x to the 5th. It's one of those times you're going to have to pull an old tool out of your tool belt to help you solve a current problem. 25x squared minus 4y squared. They're all squares and it's a difference. So 25x squared, that'd be a 5x and a 5x minus a 2y and then plus a 2y. 12x cubed minus 3x. Well, it's not a difference of two squares, but it's going to get me there because, first of all, I can factor first a 3x out of the problem. Then I'm left with a 4x squared minus a 1. And then this 4x squared minus 1 is indeed a perfect square. So I'll keep my 3x. Then I'll be left with a 2x minus 1 and a 2x plus a 1. And then lastly, x to the 4th minus 81. I'll be left with x squared minus 9 and x squared plus 10. Every time I get done factoring, I want to check to see if I can factor further. And it looks like that this one did produce x squared minus 9, which is also a perfect square. So, or a difference of two squares. So I can factor that again. The x squared plus 9, although it looks like the difference of two squares, it's actually a summation of two squares, and those do not factor with our real numbers. So I can rewrite this one as x squared minus 9, that's actually an x minus a 3 times an x plus a 3, and then this x squared plus 9. So if you're able to identify anywhere in the process a number that's a difference of two squares, it might be helpful to remember that it always factors down to a plus b times a minus b.